In this lesson, we're going to talk about side-side-side congruence and triangle rigidity. This is going to be a very different kind of lesson because it starts out just by showing you a lot of pictures of how triangles are used in all kinds of facets of the world, and then I'm going to go into a little demonstration. If you have the opportunity to do this demonstration for yourself, I highly recommend it. You'll need some straws that are non-flexible, or at least the flexible stuff cut off, and you'll need some yarn. Let's talk about side-side-side congruence for a moment. This is a postulate from geometry that I'm just going to state here as a theorem, where if two triangles have all three sides congruent, then they'll also be congruent triangles themselves, meaning their angles will be the same. What this means is if you are given three side lengths, any three lengths, as long as those lengths could make a triangle, the triangle that you get is unique. It's going to have that shape, it's going to keep that shape. The only way you could modify that shape is to rotate it, flip it over, but nevertheless you have exactly the same triangle from those three lengths. Triangles are what we call rigid. So we call this triangle rigidity. And the triangle, as far as we can tell, is really the only practical shape that has something of this nature. So let's look at where triangles show up all over the place. The first example is the Great Pyramids of Egypt. You'll notice that these triangles were used thousands of years ago. People knew way back then that the construction of buildings would help when you had triangles involved. Triangles also show up in nature. Here's just a nice flower that you can look all around and you'll see lots of triangles in this thing. This plant has many triangular leaves. You can see them all over the place, and they sort of have this interesting spiral pattern as well. Here's a really large triangle. Even the very mountains that we see tend to often have a semi-triangular shape. It's just structurally sound for a mountain. Now we can use triangles for all kinds of things. Here's an example of using triangles as a bookshelf end. Here's an instrument that we simply call the triangle. It's a good shape in order to make the sound that we seek. Here's an example of an object that we call a prism. Because of the nature of its shape, it actually has the ability to bend light and show us the rainbow coming from simple white light. If you got that reference, congratulations. Now let's talk about structure that involves triangles. Here's an example of a kite. The reason that the kite has structure is because it's built up of four smaller triangles. Here's an example of a children's play area. Notice that the entire thing is made of triangles, all fit together so that it does not move when the children are underneath it. Here's a very important example of triangles. The roof of pretty much every house has a slant, and that slant has lots of triangles. Lots of different designs are available, but there are many triangles that keep it together. You see many triangles in the design of this window that also help keep this roof up. These objects not only have a triangular base, sort of to have what we call a tripod, but they come up and create triangles to hold in place whatever they're trying to hold on top of them. My guess is that these are for holding speakers. You've definitely seen some variant of this in your house. The triangular shape of a coat hanger makes it so that it actually holds your clothes without them just falling. This Ferris wheel has so many triangles on it. If you look, you can see the many uses of triangles. The various spokes have a triangular shape. From the inward, and then a little bit further out, a little bit further out, there's a triangle that holds many different ways of making sure this thing is stable. In addition, the entire structure is built on a triangular base that's holding the centerpiece up. There's so many triangles in this shape to make sure that nobody falls off. A bridge is another thing that you definitely do not want to collapse. Look at all the triangles used on top and on the sides. You should definitely recognize this shape. This is the Eiffel Tower. It has so many triangles in use keeping it together, and its rough shape is even built somewhat like a triangle. If you recognize this one, you'll find it at Epcot Center in Disney World. This is what we call a geodesic dome, and it's made of many small triangles that together make a sphere. These are all the examples that I wanted to show you of triangles that you would see all around you. Now let's take a look at a practical example of what triangles can do in certain shapes.
In this demonstration, I'm going to show you how the triangles can be used to make other shapes solid. Let's take a look at what this would do. To do this, you will need some yarn. I have a relatively short piece of yarn here. And you'll need some straws. I have 15 straws cut to about the length of my thumb, and that's all you should need for this. Let's start off by simply putting the straws on the yarn and taking a look at what the triangle would look like. Twisting the ends of the yarn helps in putting the straws on there. Now, I've got 3 straws on this piece of yarn, and I'm going to tie it kind of tight. I'm going to pull it to the point that even the straws are buckling a little bit. And when I do this, I'll get a nice solid single knot, and then I'll get you a double knot here. And this is your initial triangle. Now, what's so special about this triangle? This triangle is what we said to be rigid. Rigid meaning you cannot move it. It's pretty well holding its shape in this context. You cannot make it change to a different shape other than maybe bend the straw material, that sort of thing. This triangle is rigid. Now, what if I were to try to do that for a square? Let's see what it looks like. I'll take my second piece of yarn and I'm going to put 4 straws on it this time. Okay, I have 4 straws. Now let's just tie them together just like I did with the triangle. Again, tie it nice and tight. If the straws buckle a little bit, that means you got it nice and tight. And then I put in my double knot and I have a square. It's not a square, is it? I can probably sort of force it to look like a square. And you'll notice herein lies the problem. It's not rigid. I can change its shape. This is the problem with objects that are not triangles. They don't hold their shape. So how do we correct this issue? How do we make them hold their shape? Well, the solution is triangles. So what I'm going to do is add triangles to this shape to try to make it rigid. Now, looking at how much yarn I have left over, I think I'm okay here. I think I'll only need 5 pieces of string for mine. What I'm going to do is tie string around each of these 4 corners, and I'm going to tie it in half. So I'll just take another piece of string here, get it in half, and just kind of pull it into place, and then I'll tie a double knot here. In doing so, I'll just be getting the string ready to help me add some triangles. We'll continue this process going all the way around adding string. Remember to double knot with each one or else it'll come loose. So now take a look. I have string on each corner, and so now I can take this square and figure out a way to put triangles on it. I'll show you the technique that tends to work the best. And by the way, you might see some of the shapes around me right now. This is my partially completed snub dodecahedron. It's a shape that has pentagons and triangles. You'll notice on every pentagon, I've got this white face here of almost a pyramid shape. And this is going to be my inspiration for how I'm going to do this. Let's add some triangles on each corner, and then, well, not really adding triangles. Let's add some straws on each corner so that when I put them together, it'll make a triangular pyramid on top. That should do the trick. Okay. Notice that I have put 2 straws on each corner. I'm just going to tie these 2 together to form a triangle. Again, tie your string nice and tight. It really helps in this regard. All right, I have 1 triangle. Now, how are we going to add another triangle to it? Well, you might think, let's put a triangle on this side. But I'll tell you now, even though you can do that, I'm thinking more about a pyramid. So what I'm going to do is take this and then put another straw up to it to make this pyramid shape. I have my straw. Now I will tie it to the existing top where I was working on the pyramid before. Remember, when you tie these, tie them nice and tight and always do a double knot. All right, now where do we stand? We've got a triangle starting to come to play. You see two triangles here on top of my square. And now I'm going to put one more straw on this piece of string, tie it to what I have, and I should have a pyramid. Okay, we have a bit of a pyramid shape. Looking down at my knot, it looks pretty good. I don't see any openings or gaps. It's nice to kind of check it and see, but it seems okay. I have a pyramid, and now look. The length of my straws might not be perfect, but this is kind of holding its shape. Or so it seems. So let me show you what is still not quite there. I have very close to a square, but something's not quite right. This may look familiar. It's only our textbook for the course. Just using it as a surface here to show you that when I put this down on a surface, it holds its shape. This square is solid when it is flat. However, 3 dimensions allows for things that you might not expect. So while this looks like a square, let me show you something. From this perspective, you might not be able to see what just happened. How did I do that? Maybe a different angle will show you. It's bowing downward. This is the square shape, but it's coming downward in 3 dimensions, and it's able to get rid of that square shape. So what is the solution? The solution is even more triangles. So what I'm going to do is turn around and put a pyramid on the other side of this square, and then we'll see what happens. Again, I've already got some string hanging out. This is why I tied it in half, because I kind of knew I was going to need some extra. If I put triangles on this side of the square, we will be in business. Now take a look. This hardly looks like the original square that I started with. This is my original square. You can sort of tell because of where I tied all my string. This was the pyramids. So my square is the center line right here. And if you look straight down it, it does look like a square, but now there's nothing that I can do to bend this out of shape. There are so many triangles, 8 as a matter of fact, holding this together, that this shape is going to hold solid. Now there's a little bit more reasoning behind this as well. This is actually one of the 5 platonic solids known as an octahedron. Octa meaning 8 triangles. But from a cross-sectional point of view, you can see that it contains squares that are firmly holding their shape because of all the triangles around it.